Alright folks, today we're working on evaluating 1.4, which is evaluating functions. So first let's talk about what the heck is a function in the first place. So a function is just a relationship that relates, it processes, so relationship that relates, which is kind of redundant, a set of input values, which we like to call domain, which remember is our x values, to a set of output values, which we like to call y, but we're also going to start calling f of x or g of x or h of x as it comes along, which is also called range values. So set put output range, let's cross off output, and let's set up output, or so range values. Okay, so function is a relationship that relates a set of domain values to a set of range values. So we've seen functions before. We usually like to write them as like y equals 2x, or like y equals x squared, things like that. So the special thing is that for each domain, for one domain, we have precisely one range value. So if I was to put in a number here, so if I said like x equals 1, right? So then I'd say y equals 2 times 1, which is going to give us 2. Unfortunately, this notation is kind of funky. So our input here would be 1, our output value would be 2. So we're going to start write things similar to what you see down here at the bottom of the screen. Instead of writing it with y equals, you're just going to write f of x equals, and there's to be some relationship over here. So this is going to be our both the name of the function is called f, so just underline the name of the function, and then this is also going to say, hey, when we have our input value, which is by the way our x, our domain, so this is going to be the name of the function, the input value, and whatever else is at the end is going to be our output value. So let's just do an example down here with these examples. So I've got f of x is going to equal 3x, g of x is going to equal x squared, and h of x is going to equal 4. So the reason that we have this f here for the name of the function is just to differentiate it with what function you're talking about. So in this one we're talking about some f's, and this one we're talking about g, and this one we're talking about h. So if I said find f of 3, you know which function to look at. G of 3, you're going to look at the g function, and h of 3, you're going to look at the h function. So we're going to write it like this. So we say we're finding f of 3. So we're going to write f of 3 is equal to, and we know that f of x, so if we change this x to 3, what we do to one side of the equation, we do to the other. We're going to change this other x also to being 3. So the 3 comes down, and we replace this x with a 3. So f of 3 is going to be 9. So if we look at these two styles, right, so back in Algebra 1 versus an Algebra 2 style, I said, hey, let's put an x of 1 in here. We'll say y equals 2 if you were to simplify this and write it correctly with one equal sign per line. It doesn't tell you your input. It only tells you your output. And you're not even sure which equation you use it for. If you had two different equations, you're like, hey, I don't know which one this is going to be used for. That doesn't make any sense. Instead, we can say, look at the f function. If you put in 3, the output is 9. f of 3 equals 9. This is not f times 3. This is set as f of 3 equals 9. And this is how you would say this thing. So this is done. You don't have to do anything else to it. You don't have to divide by 3. This is not f times 3. This is f of 3. So my f function evaluated at 3 puts out an output of 9. We can do the same thing for g of 3. So if we're looking at g of 3, we can copy down g of x if you'd like to, equals x squared. So then we're changing x to 3, because the stuff inside the parentheses changes from x, it changes to 3. So g of 3 equals, let's see, x squared, we're replacing x with a 3. We're not changing anything else, so that still needs to be squared. And then we just simplify the right side. 3 squared means 3 times 3 is going to give us 9. So g of 3 equals 9. And you should practice saying that a couple times. This isn't g3, it's g of 3, or f of 3, or h of 3. Your function name, the input value, equals 9, or is 9, something like that. Alright, so let's look at the last one. H of 3, so h of x is equal to 4. So h of 3 is going to be equal to, well, we have a 4 here, but we have no x to replace it. So if we're not replacing the x at all, we're not going to change this at all. which says that it doesn't matter our input value, we're always going to have 4 as our output value. So we're going to say h of 3, that's it.
That's all we have to do. So the interesting thing about functions is that you don't always necessarily need to put in just a variable or just a constant, just a number. We could also put in input values. So if you were like, hey, multiply something by 3 and then multiply by something by 2, you could just write that as one expression, which is what this one is doing. F of x says take an input value multiplied by 3, but I want to say, well, what if we actually multiplied it by 2 later on? So we'd say f of x is equal to 3x. Our x is going to change to 2x, so our input value is 2x. So we're going to replace the x. We're going to say, hey, instead of writing an x, we're going to write 2x. So we're not changing the 3 at all. But we're replacing this x with, just like we replaced this x with 2x, we're going to replace this x also with 2x. And then we can simplify that. So f of 2x is equal to, let's see, 3 times 2 is 6. There's an x that comes along for the ride, and that's it. We can't simplify that any further. So f of 2x is equal to 6x. That's all there is to it. Just do whatever it says. In this case, we replace x with 2x. So 3 times 2x is 6x. Okay, let's do the same thing for g. So instead of squaring something, we're going to square something and multiply it by 2. So g of x is usually just x squared. I'm replacing x with 2x, so g of 2x is going to equal, replace the x and not the squared, and I'm replacing the x with 2x. So remember, 2x squared is to say 2x times 2x. So g of 2x is going to equal, let's see here, 2 times 2 is 4. X times x is x squared. So g of 2x is equal to 4x squared. Okay, last one. H of 2x. So copy down h of x again is going to equal 4. So h of 2x is equal to 4. We don't replace anything at all. There's no x value for us. There's nothing for us to do. So h of 2x is equal to 4, which is kind of funky. It looks like whatever's happening for this h function, we're always getting 4 as a result. So not every single time will I give you a list of them and say, hey, find everything. I mean, I'm just doing it right here so we can see what happens when we have numbers. What happens when we have variables. And then the last one, I'm not doing all of them. We're just doing a couple of them. We're looking for not just a single term, but when we have 2 terms, what happens when we plug that into our equation? So remember, f of x, same f of x until we change it on a separate page, is equal to 3x. So 3 times your input value. So if I say f of x is being replaced with x minus 5, whatever is written right here, just copy it down, make it look like that. That says 3 times, well, this x changed to x minus 5, so let's change this x also to x minus 5. So 3 times the thing, so let's open it to distribute. We've got some parentheses, so 3 times x is 3x, 3 times negative 5 is negative 15. And f of x minus 5 equals 3x minus 15. So we can put expressions in here beyond just single variables, beyond just one term, beyond just numbers. We can make them as complicated as we need to. For right now, we're going to keep it relatively easy so that you guys are good to go on it. So h of x, let's look at that one as well. H of x minus 5. Well, we know that h of x is going to equal 4. So if I replace h of x with x minus 5, there's nothing to change again on the right side. So this thing on the right is kind of a special one, and you'll see this every once in a while. It's always going to give you a constant value out. Sometimes they're just tripping you up. They're saying, hey, this thing always equals 4. It always equals 4. So it doesn't matter what you put in, you're always going to get 4 as a result. Okay, we'll get some practice in this. Make sure that you ask questions as you need to. Grab the 1.4 sheet. Let's get to work.